All right, cloud security pros. If you're here, you're probably hitting those CCSP study guides hard.
That's great.
Yeah, it's a tough cert, but it proves you know how to lock down the cloud.
It really does.
And today, we're diving deep into something that's not just on the CCSP exam, but a real-world must-have: cryptography.
Absolutely.
Now, before you think you're going to get all math textbook on you, I promise we'll keep it interesting.
Right.
We're here to bring this stuff to life.
Exactly. You know, what's really cool about cryptography is it's more than just scrambling data.
Yeah.
It's really about achieving specific security goals. It's
Yeah.
almost like, if you have a lock that you're trying to pick, you need a specific tool, not just any tool.
I love that. The right tool for the job.
Exactly.
Okay, so for someone staring down that CCSP exam, what is cryptography in the simplest terms? I know our source uses this recipe idea, which I think is kind of fun.
Yeah, that's a good starting point. Think of your data as ingredients.
Okay.
And the encryption algorithm is the recipe.
Okay.
Combine them, and boom, you've got your secret sauce, a ciphertext.
Yes.
But the why behind it is crucial for the exam.
Right.
It's not just making the data unreadable. It's about things like confidentiality, integrity, proving who sent something. There are layers here.
Okay, yeah. And speaking of layers, our source goes into symmetric versus asymmetric cryptography. And it uses that Alice, Bob, and Charlie example, which honestly made me chuckle thinking about, needing a zillion keys if you've got everyone in a company.
Right. Imagine a cloud provider trying to manage keys for millions of users.
Oh my gosh.
With symmetric encryption, it would just be a nightmare.
Yeah, that's a lot of keys.
Yeah.
Yeah.
Asymmetric solves this really beautifully with key pairs,
Okay.
public and private, and the source stresses that these keys come as a pair.
Right.
That's a key concept.
Yeah.
Pun intended for the CCSP exam.
I see what you did there.
Yeah.
Okay, so is it kind of like having a mailbox that anyone can drop stuff into? That's the public key, but only you have the key to open it.
Exactly. And that's really critical in cloud environments where you've got so much communication happening between services, users, applications. Asymmetric keeps things secure without needing a key for every single interaction.
So we've got the what of cryptography, the types of cryptography.
Right.
But now let's get into the why it matters.
Right.
For the CCSP exam and, frankly, anyone working with the cloud these days.
Absolutely. You think about all the sensitive data that's living in the cloud. Financial records, healthcare info, proprietary code. Cryptography isn't just about keeping that confidential. It's about guaranteeing that it hasn't been tampered with, that it came from the right source. All of these things are really important.
Right. And this ties back to those 5 goals of cryptography that our source outlines.
Yes.
Confidentiality, integrity, authentication, obfuscation, and non-repudiation. It's a mouthful, but it's important stuff.
Absolutely. Understanding those goals is key.
Right.
And they're not just theoretical concepts like confidentiality. Imagine a hacker trying to peek into your cloud storage bucket. Encryption is your lock. Integrity ensures that the software running on your cloud server hasn't been messed with. Authentication verifies that it's really you logging in and not some imposter.
Right, right. And so this is all tied into cloud security, like in a very real way. This isn't just abstract concepts.
Exactly. And it's applying these concepts to real-world cloud scenarios that the CCSP exam will really test you on.
I see. Okay.
Like obfuscation might be your cloud provider swapping out your actual credit card number with a token.
Okay.
Or non-repudiation.
Yeah.
Ensures that someone can't deny sending a message.
Right.
Kind of like a digital receipt.
Okay.
But it's important to note, our source says this is only possible with asymmetric cryptography. Why do you think that is?
Well, with symmetric, I mean, if they share a key, then Bob could have forged that message.
Exactly.
But if it's signed with Alice's private key, only she could have done that. So that's a good little CCSP exam tip to remember.
Sharp thinking. See, these concepts aren't just for passing an exam. They're the bedrock of securing cloud services these days.
Absolutely, yeah. And it's only getting more complex out there.
For sure.
Okay, so we've laid some serious cryptography groundwork, types, goals, why it matters in the cloud.
It's important stuff.
It is. But I'm ready to get a little bit more hands-on now.
Okay.
Our source dives into specific algorithms.
Right.
And, for someone prepping for the CCSP, this feels like where the rubber meets the road, right?
Absolutely.
Yeah.
Knowing the theory is essential, but the CCSP exam will definitely test you on understanding how these algorithms work in practice, especially in cloud environments.
So let's jump into it.
Okay.
Where do we begin on this cryptographic algorithm tour?
Let's start with a heavyweight champ, the Advanced Encryption Standard, AES.
Okay.
It's a symmetric block cipher that's basically the gold standard in many areas, including cloud security.
AES, yeah, I've definitely seen that name pop up in my CCSP study materials.
For sure.
What makes it so popular?
Well, it's known for its robust security and efficiency. It's even been adopted by the U.S. government for protecting sensitive data.
Wow.
So, it's got to be tough to crack.
So AES is like the Fort Knox of encryption algorithms.
It's definitely up there. It uses different key lengths, 128, 192, or 256 bits. The longer the key, the harder it is to break. And that's something to keep in mind for the CCSP exam. They might ask you about the strengths of different key lengths.
Okay, makes sense. More bits, more security.
Right.
But hold on, isn't AES a symmetric algorithm?
Yes.
And didn't we say that symmetric encryption can get messy for large organizations because of all those keys you have to manage?
That's true. Symmetric encryption does have that scaling limitation, but for certain scenarios, like encrypting data at rest,
Okay,
it can be incredibly efficient.
I see.
Like, think about a cloud storage service with millions of users. Encrypting each individual file with AES is way faster than using asymmetric encryption for every single one.
So it's all about choosing the right tool for the job, considering both security and practicality.
Exactly.
That's a good point for the CCSP exam. It's not just about knowing the algorithms, it's about understanding when to use them.
Exactly. Now, while AES is great for securing data at rest, it's also widely used for data in transit.
Okay.
Think about VPNs, TLS connections.
Wait, TLS?
Yes.
That's what secures our web traffic, right?
Right.
When you see that little padlock icon in your browser address bar.
That's the one. AES is a core part of TLS, making sure that data zipping between your computer and a website is safe from prying eyes.
Oh, cool.
And speaking of securing communications, let's move on to another big player, RSA,
Okay.
which stands for Rivest, Shamir, and Adelman.
RSA, another name I've got scribbled all over my CCSP notes.
Absolutely.
This is where those public and private key pairs come in, right?
You got it. RSA is the foundation of a lot of asymmetric cryptography out there. It's used for things like secure communication, digital signatures, key exchange. It's a real workhorse.
Okay, so humor me for a second.
Sure.
Explain public and private keys again. Like, I'm 5. I know we talked about it a little bit before, but it still feels kind of magical to me.
Imagine you have two keys that are mathematically linked.
Okay.
You keep one key hidden. That's your private key, your secret decoder ring.
Okay.
The other key, your public key, you can give it to anybody. You can shout it from the rooftops.
Okay.
Give it to anyone who wants to send you a secret message.
So anyone with my public key can encrypt a message, but only I, with my private key, can decrypt it.
Exactly. And what makes it magical is the math behind it. It's virtually impossible to figure out your private key just by knowing your public key.
So even if someone intercepts the message and they have my public key, they can't read it without the private key.
Right.
Okay. Phew. That's good to know.
It is.
But how does this apply to the cloud? What should someone studying for the CCSP exam be focusing on here?
Well, RSA is everywhere in cloud environments. Think about secure shell SSH connections for managing cloud servers.
Oh, yeah. Okay.
Your commands and servers' responses are all encrypted thanks to RSA.
So no eavesdropping allowed.
Exactly. But RSA isn't just about secure communication. It's also a key player in digital signatures.
Right. Digital signatures.
Yes.
Our source mentioned them as a way to verify the authenticity of a message, kind of like a digital fingerprint, right?
Perfect analogy. So let's say you need to prove a message came from you and hasn't been tampered with. You create a hash of the message.
Okay.
This is like a unique digital fingerprint. Then you encrypt that hash with your private key.
Okay.
And that encrypted hash becomes your digital signature.
So I attach the signature to my message, send it off.
Right.
What happens on the receiving end?
Well, the recipient uses your public key to decrypt the signature, revealing the original hash. Then they create their own hash of the message. If the two hashes match, boom, they know the message is authentic.
Oh, wow.
It came from you. It hasn't been messed with.
That's so clever.
It is.
Only you, with your private key, could have created that signature. So RSA is behind both secure communication and digital signatures in the cloud. It's like the multi-tool of cryptography.
Another great analogy. And remembering these real-world applications of RSA will definitely come in handy on that CCSP exam.
All right, so we've got AES for securing data, RSA for secure communication, and digital signatures.
Right.
But I have a feeling this is just the tip of the cryptographic iceberg.
You're absolutely right. There's a whole universe of encryption algorithms out there, each with its own strengths and
Oh
weaknesses.
boy.
And the CCSP exam will likely touch on at least a few more.
Okay, so how do you even begin to choose the right algorithm? Like, is there a magic formula?
Unfortunately, there's no one-size-fits-all answer.
Okay.
It really all boils down to the specific security needs, the type of data that you're protecting, and even the limitations of the cloud environment you're working with.
So it's about understanding the trade-offs.
Yeah.
Maybe a super strong algorithm is overkill for some situations,
Right.
or maybe it's too resource intensive for your cloud setup.
Exactly. And that's a key takeaway for anyone prepping for the CCSP. You need to be able to analyze a scenario and choose the most appropriate encryption method.
Yeah.
It's not just about knowing the names, it's about understanding the why behind each choice.
Okay, that makes a lot of sense. So we've gone from like the basic building blocks of cryptography to specific algorithms like AES and RSA
Yes.
and how they fit into the cloud world.
Right.
Where do we go from here?
Well, the world of cryptography never stands still. New threats emerge, new technologies arise, and one of the biggest game changers on the horizon is quantum computing.
Quantum computing.
Yes.
Now that sounds like something straight out of a sci-fi movie.
It might sound futuristic, but it's closer than you think. And it
Oh.
has the potential to turn the world of cryptography upside down.
Okay, now I'm intrigued and maybe a little bit scared.
Yeah.
We'll have to save that quantum discussion for part 3 of our deep dive, though.
Sounds like a plan. We'll explore the challenges and opportunities of quantum computing and what it all means for the future of cloud security.
Can't wait. Okay, we're back for the final part of our cryptography deep dive. And things are about to get, well, seriously futuristic.
They are.
We've covered the basics, explored algorithms like AES and RSA,
Mm-hmm.
but now it's time to talk about something that could change everything. Quantum computing.
It really could. It's not
Yeah.
just science fiction anymore. Quantum computing is advancing so rapidly, and it has the potential to really reshape the entire landscape of cybersecurity, especially when it comes to cryptography.
I'll admit I'm a little nervous just hearing those words. I know quantum computers are incredibly powerful, but how exactly do they threaten the encryption that we've been talking about?
Right.
You know, we spent all this time learning about AES, RSA is all about to become, like, obsolete.
Well, it's not an instant game over situation, but it is a serious concern. You see, a lot of today's most common encryption algorithms, including RSA, rely on mathematical problems that are really tough for classical computers to solve. But for quantum computers,
Right.
they're a piece of cake.
Oh, no. So a quantum computer could just, like, waltz in and crack the codes that are protecting all of our data. That's not a comforting thought.
No, it's a real possibility, which is why the field of post-quantum cryptography is just exploding right now.
Okay.
Researchers are scrambling to develop new encryption algorithms that can stand up to both classical and quantum computers.
Wow. So it's like a cryptographic arms race.
It really is.
You know, the code makers versus the code breakers, but with, like, quantum weapons on the table.
Exactly.
What are some of these new quantum-resistant algorithms like?
Well, there are a few promising contenders out there, things like lattice-based cryptography, code-based cryptography, hash-based cryptography.
Wow, these are some big words.
Yeah. They're all based on different mathematical problems that, so far, even quantum computers seem to struggle with.
Okay, so it's about finding those new mathematical fortresses that can hold up against this, like quantum onslaught. But switching over to all these new algorithms sounds like a massive undertaking. What does that mean for the future of cloud security and for someone studying for the CCSP exam?
It's definitely a huge challenge, but also a really exciting opportunity. As quantum computing matures, we're likely to see the sort of gradual transition to these more robust encryption methods.
Okay.
And for someone preparing for the CCSP, understanding these emerging trends is absolutely critical.
So it's not just about memorizing the algorithms of today, it's about being aware of what's coming down the pipeline. How do you stay ahead of the curve?
I think staying informed is key.
Okay.
Keep an eye on research coming out of organizations like NIST.
Okay.
They're really leading the charge on post-quantum cryptography standards. And remember, the CCSP exam is all about real-world application. So think about how these advancements might impact things like cloud security architectures, key management, incident response.
So quantum computing is a big deal, but it's not the only thing that's, shaking up the world of cryptography right now.
No, absolutely not.
What other trends should cloud security pros and CCSP hopefuls be paying attention to?
Well, one key trend is the rise of homomorphic encryption.
Homomorphic encryption.
Yeah.
Okay, I'm going to need you to break that one down for me.
It's kind of a mind-bending concept, but imagine being able to perform computations on encrypted data without ever decrypting it.
Wait, seriously? That sounds like magic. How is that even possible?
It involves some very complex math, but the implications for cloud security are huge.
Okay.
Think about being able to process sensitive data in the cloud without ever actually exposing the raw data.
Okay.
It could revolutionize industries like healthcare and finance.
That's incredible. It sounds like cryptography is becoming more and more powerful and sophisticated all the time. I mean, it's a bit intimidating, but also super exciting to be working in this field right now.
It really is. It's a constantly evolving landscape, which means continuous learning is a must. Never stop exploring, asking questions, pushing the boundaries.
Well said. So we've covered a ton of ground in this deep dive, from, the fundamentals of encryption to the quantum revolution that's on the horizon.
Yeah, we did.
Hopefully our listeners are feeling a little more confident about tackling that CCSP exam
I hope so.
and, more importantly, ready to face the ever-changing world of cloud security head-on.
Absolutely. And remember, cryptography is such a powerful tool for protecting data, securing systems in the cloud. By understanding its principles, staying informed about these new developments, and applying best practices, we can build a much more secure and resilient digital future.
And on that note, we've reached the end of our cryptography deep dive. We hope you've enjoyed the journey and found it both informative and engaging.
A huge thank you to our listeners for joining us on this adventure. Keep exploring, keep learning, and keep pushing the boundaries of cloud security. Until next time, stay safe out there in the digital frontier.